All attendees are in listen-only mode.
Well, good morning, everybody, and welcome to our webinar today titled Eliminating Bottlenecks in Your CNC Processes. My name is Rob Romanowski. I'm the Director of Operations for Three HTI, and I'm joined today with John Dieselet from NC Simul. And we've got a very informative webinar for you this morning, and I hope that you all get a lot out of it. So I'm going to do a brief overview about 3HTI and who we are, which hopefully will take only about 3 minutes. And then I'm going to pass everything over to John, who's going to go a little bit more detailed concerning some areas of issues common areas of issues and bottlenecks in the CNC process and some solutions that are available. Now, before we get started, just a couple of housekeeping items. I want to let everybody know that you're going to be on mute during the webinar. That is not personal. It's not that we don't like you. We love you. But just to keep any background noises, from interfering with the webinar, we're keeping everybody on mute. If you have any questions, we're going to have a Q&A session at the end. However, if you have a question ahead of time, please type it into the questions box in your dashboard, and we will either answer it during the webinar or we will definitely answer it at the end. So before we get started, I want to ask you guys a couple of questions to figure out a little bit more about our audience, and this gives us a better understanding of what your background is. So first question is, what type of CNC software are you currently using? And John, I'm guessing that you can see my screen?
Yes, that's correct.
Cool. And there is more than one answer. If you're using more than one solution for your CNC software, you can check more than one answer. All right, I'm going to close this. Next question. How many CNC machines do you have on your shop floor? All right, I'm going to close this one out. And last question. How many CNC programs do you generate per month? I'm going to close this question out. Thank you very much for participating. So quick overview about 3HTI and who we are, because we do have some people who are not currently 3HTI customers on the webinar today, which is great. We always love visitors and new people. Basically, our focus as a systems integrator for various software and hardware solutions for companies in manufacturing, our mission is really to try and help people live better lives. And ultimately, we do this by helping our clients create better and more innovative products. And we can do this by improving a company's competitiveness related to product lifecycle management by providing a myriad of technology solutions and services to help them adopt and maximize these technologies, which allows them to develop and manufacture products better, quicker, and definitely more cost-effective, improving profitability and competitiveness. But ultimately, and this might sound corny, but this is kind of how we feel, is that if you're able to do your job better and it makes you have an easier day, or you can get out of the shop earlier and spend a little more time with your family or do something more that you enjoy outside of work, that helps to lead a more well-balanced life. I mean, we work really hard here at 3HTI. We work, we work long hours, but we also enjoy the time that we have outside of work, and we try to instill that and help out our customers achieve the same kind of pleasure outside of your workspace. So we provide a host of solutions starting with concept design all the way through manufacturing, including end of life cycle management. And we look holistically at the customer's requirements and listen to what the problem is rather than trying to sell or push a piece of technology. We are not software peddlers in any way, shape, or form. We are trying to help people solve problems. This is a host of solutions that we offer. As you can see, NC Simul, which we're going to be focusing a little closer on today concerning solutions for manufacturing. But we also offer analysis solutions with the suite of Mentor Graphics products, which basically helps put an analysis software in the hands of a designer to help understand what the functionality of their design is going to be early in the design process. We also sell 3D printers. We're a reseller for Stratasys as well as Mark Forged, which has a prints in carbon fiber. So what's interesting about that is from a machining standpoint, it reduces the need for prototypes because you can print a part that is just as strong as aluminum by printing nylon with carbon fiber mixed in. We also just became a reseller with EnvisionTech, which has the highest precision as far as 3D printers are concerned, and they also have a series of bioplotters for the med device and pharmaceutical industries, which is pretty exciting and really cool. We also sell or provide solutions with product lifecycle management with PTC Windchill and CAD software solutions with the PTC Creo suite. Here's a list of customers that we've done business with over the past year. And the interesting thing about this list is it kind of looks like the who's who of people within their industry, but these aren't, these are pretty popular, well-known names, but we have customers of all sizes. So it doesn't matter what size your business is. Our focus is to say, what is your problem and how do we fix it? And, we don't necessarily give special treatment more so to one customer than another. We give all our customers special treatment because that's just how you should run a business. But I think the reason to have these customers listed here is so that you who may not be familiar with this can see that we're pretty diverse in the industries that we work with, and we've solved a lot of problems. And one of the things that we've done is 2 years ago, back when Penske Racing won the Sprint Cup in NASCAR, we actually worked on a machining project with Penske Racing on their CNC machines back in, I believe it was June or April of 2 years, or May or June of two years ago. So that was a pretty exciting project to work on and see it have the influence. And I actually have an email from John Maloney, the general manager of Penske, that says that 3 HTI should take satisfaction in every Penske victory. So basically, whatever the issue is, we're here to help you out. So at this time, I'm going to pass everything over to John Dieselet, who is the applications engineer with NC Simul. And John has about over 10 years experience in the manufacturing industry. He has been with Spring Technology for the past 4 years, but before that, he spent time as a machinist, an operator, and a CNC programmer. So he brings a lot of knowledge to the table, and John, we're real excited to have you here today. And what I'm going to do is I'm going to pass you control. And now the presentation is all yours. Thanks, everybody. Thank you, John.
Excellent. Thank you, and thank you, everybody, for joining us today. A lot of the things that I'm going to be going over are related to how you can refine your manufacturing process and make things a lot smoother and clear up the bottlenecks that are everyday problems that you face today. The first thing that I'm going to go over with you is an interface between your CAM your CAM software into our simulation software to prove out the G-code simulation. So in this first demonstration that I'm going to be showing you, I'm going to have a CAM project in MasterCam. that you can run an interface that will directly bring all the information from your CAM system directly into NC Simul. Now this is the first step of clearing up issues of bottlenecks, because you're able to take all the information that you've already built inside of your CAM project and directly bring that into your simulation software. Now we have interfaces for Creo, Mastercam, EdgeCam, CATIA, all the major leading CAM softwares that are out there today. Just for this example, I'm going to be showing you the Mastercam. This is just my standard demo. So inside of my Mastercam project, you can see all my toolpaths in yellow. We can see that I have a part model. The stock is red, and the clamp is gray shown on the screen. Now, the plugin is just a Mastercam C-hook. For those who are familiar with Mastercam, you'll know exactly what a C-hook is. For those who don't, it's basically a macro plugin that is available with installing it as basically like an external feature. Once we execute the interface, the software begins to handshake with NC Simul Machine, allowing you to select your part model, any fixtures or riser plate, and finally your stock model. The only thing is right now my stock model is not visible in the screen. Here we can also export all the tools, the G-code program, and even select where we want to export the models from if we want them orientated differently on our machine. The reason we do this is because sometimes your world origin is set up at your program 0 and your models may be positioned differently. That's okay. With NC Simul Machine, with the interface, you're able to export from any plane or dynamic work position that you create inside of your software. After we run the interface, you just simply save and click OK, and the software will automatically run inside of NC Simul, and we can see that inside of my machine, this is the project that came in from Mastercam. If we zoom in, we can see I'm going to make the part visible and show you that the models came in nice and neat, very clean. The rendering is nice and smooth. It's very easy to manipulate. We can turn on and off the toolpath preview of all the tools, and we can even look to see if there's any issues for positioning on the table. If there is a problem and it didn't come in correctly, that's fine. You can simply right-click on any one of the 3D elements, do a set position, and rotate the part around for easier setup and to better have it accessible for your operation on your machine. Now, right from the interface, the very first thing that NC Simul did was it scanned the G-code looking for syntax errors. Now, this is very important because you want to be able to right away find out if you have any O's instead of zeros, commas instead of periods, a lot of things that if you do any manual edits to your G-code, you wouldn't normally be able to catch by eye. The software automatically scans every single line of code, searching for these anomalies. In addition to that, checking for over travels. So here I have an over travel of the Z-axis of this tool, and I can filter out just this loaded tools toolpath. So this shows me right here that I have an over travel of the Z-axis. It shows me where. It tells me what tool number I'm working off of, what height offset, and if I go to my status tab, it gives me any additional information of this tool. This is tool number 4, this is my LTR jobber drill, and it's telling me my rotation and spindle direction. So this is all valuable information for your operator to understand and know to debug and troubleshoot the CAM project. So right from here, instead of NC Simul, you can simply say edit. I can change this from 18 to 15. And at my other zebra track point, I have the change is right here. Once I save and click OK, the software then rescans the G-code, making sure I didn't accidentally put in a comma instead of a period. And after it's done doing the rescan, we can see that we no longer have the over travel, and the software allows us to continue moving forward onto simulation. Now, how does this help you? Where does this come into play? For all of us who have ran and operated a machine or done any edits on a machine, it can be the difference of a decimal point that makes or breaks a part or makes or breaks your machine. So just a decimal point or even just a few inches can be the difference of a lot of headaches, downtime, and potentially ruined equipment. So now we can see that the over travel is complete, and I no longer have any alerts, and my alerts tab allow me to continue into simulation, which is step 2. Going into step 2 of simulation, what I'm able to do is I can check now for collisions of the machine axes or the tools or any type of possible problems that could happen on the actual physical machine. So here, when we begin running the simulation, the first thing that NC Simul will do is begin removing material. So right away, I can zoom, pan, and rotate, and the tools are running and removing the material. Now, at any time, I can pause the simulation. I can put material back on that I just removed and move forward back through the program up to that point that I stopped it at, and I can just continue right from here. I can even take a measurement. If I do a point-to-plane measurement, I can right-click on the side of the face here and right-click here, and it gives me the value in inches or millimeters depending on your preference. Now, I just temporarily paused the simulation. I didn't stop it. So here I'm just going to say remove my measurements, go back to simulation, and continue running my simulation. With NC Simul, its versatility allows you to find those little trouble areas very quickly and efficiently. As we run through, I'm going to speed up the simulation a little bit. When we have a problem, NC Simul is going to give us a detailed report, show us where and how it happened. So right now we have a collision of the Z-axis and the stock. So if I click on the collision and zoom in on the tool, we can see that I've rapided into the actual stock with my holder. So this tool right here is not appropriate for this operation. As we can see, it rapided into the stock trying to machine the shoulder. That's no problem. With NC Simul, we're able to actually take this tool and modify it on the fly to know exactly what we need to machine the shoulder. If I go into my tool library, I can simply say, okay, for this tool, I obviously need a greater flute length. So instead of modifying the G code, I need to actually modify the geometry of this tool. The overall length, I will change to 1/2 inch, and the cutting length, 0.475. The changes are saved dynamically, which allows you to save and continue the simulation right from that point. How this helps you in the long run is that after we've modified our tools, NC Simul also allows you to create a setup sheet that you can then give to the shop floor for them to analyze all the tools and assemblies to correctly set up for their projects. Here we can see that now I have more than enough flute length to machine that shoulder, and if I press the play button, the software will allow me to pick up right from where I left off, and I will restart one block before, and NC Simul picked up right from where I left off. This is a huge factor because you don't want to have to stop the simulation, pick it up again, stop the simulation, pick it up again every single time you make a correction. You want to be able to pick up right from where you left off and continue, especially on longer running projects. This last collision is very unique, as this type of collision is very difficult to see inside of a lot of CAM systems. Here I have a G80 canceling my drilling cycle, and if I filter out just the loaded tools toolpath, we can see that when I rotate on the B axis, I'm clipping the side of the part. Now this is notoriously difficult to see inside of CAM systems, as they show only trajectories. They don't show axis rotation going from one plane to another. So here, after my G80, I need to have a higher retract value, or on my G81, I have to put a higher retract for the argument. So simply right here, I'm going to simply say Z2 point after my G80 cycle is complete, and Z2 point on my next block, save, and OK. And just as before, the software again makes sure that I didn't have any issues with syntax error, and it's taking into account the new changes that I made to the G code. Finally, we can see now that I no longer have the issue, because now it goes to 2 inches in the Z-axis, and when I rotate around, I can clear the piece without having any collisions. Again, I'm going to pick up right from where I left off and say yes and yes to this. Finally, as NC Simula is coming to a close, we can move from our machine view to our table view. And if I go to my table view, anybody who's done any type of thread milling understands that it can be a very difficult process, especially on very small threading operations. With NC Simula, we can actually cut between two holes, which I'm about to do. If I go to Analysis Cutting Plane, I can cut between two holes. If I right-click, and click Apply, I can actually keep the stock cut in half while I run the rest of my simulation. So here it's coming in to do the deburring cycle. And it's going to be coming in to grab a few more tools. And then finally, we have my center, and then the threading operation. Now, watching the thread operation, it's very unique because we can pause this and move back and forth and putting that material back on if we would like. I just paused it for a second so you could see it. There's the first hole. I'm going to pan over to the next, and now we can watch the second hole being machined. After the simulation is complete, any surface that's been machined is given a color, and I can double-click on that surface, and it automatically calls up the tool that machined that feature. So if I want to know what machined my thread mill, I can double-click here, my chamfer, the actual thread mill itself, the location here as well. Now that the simulation is complete and you're able to know if you had any collisions or not, now where this helps you save a lot of time and money is giving it to the guys on the shop floor to understand and set up their machines a lot quicker. So with NC Simula, we have what is called NC Doc. Now, what NC Doc is a documentation software that automatically will generate a setup sheet from your simulated project. So what I'm going to do here is I'm going to get this into a nice view. I'm going to put this right here. I'm going to hit reset, and I'm going to activate NC Simula's option to take a frame on tool change and frame for documentary export. Once I've done this and I ran through a simulation, what the software will do is it will allow me to run my publication. And my publication is the automatic setup, the tool sheet setup generator. What this does is it took every single picture that I took through the simulation of the tool and what that tool machined, and allowed me to create a setup sheet from that. So here I'm just going to simply say create a setup sheet. It's going to be a normal process. And now it's gathering all the information from that simulation that we just ran. During this time, it's checking all of the pictures, all of the processes that we use for the tools 1 through 15, and all the additional information such as times, cycle times, tool change times, if you would like, the height offset values for the tools, and any other information that you want to put in as well. Here we can see that it's almost complete, generating the setup sheet for us. And once it's done, we're able to view it side by side inside of the software. So the very first thing that we have is our cover page. I'm just going to widen the screen a little bit so you guys can see this a little bit better. And the first thing that I'm going to do is I'm going to switch this to my machine view, and I want to take a nice screenshot of the 3D view just for my cover page. So I'm going to put this into a nice view so my operator knows exactly what machine it's going to and what it's going to look like set up on the machine table. So here I can say grab my 3D view, and now I can put in additional information. Another thing too is you can select the language that you would like to choose: French, English, German, Japanese, Italian, and many others. When I click accept, we can see that it automatically grabs the language that you've requested. So here I can put in a program number. I can put in a comment such as this is a Haas UMC 750. And you can put in any other information that you feel necessary for your cover page. Now, as we go through the document, if I go to the following page, it goes over each tool, and it shows you what that tool machined and all the comments and descriptions that came from my G-code program. Now, this goes for every single tool inside of my entire project. Here we can see each tool, the operation, and the comments through the entire project. Now I'm just going to keep going through the document, and as we get closer to the end, the next thing it's going to show me is the individual tools itself. So what I like about this the most is that once you get to the individual tools, if you have a special tool that you need the operator to really understand and take a good look at, you can actually double click on this picture. It brings you into a NC Simul Publisher Paint, which allows you to do annotations and edits, such as if I want to do a zoom. Let me zoom in on the tool right here. I want to then create a freestyle line where I can say I want to create a line from here to here, and I just want to put in a text that says check tool after 4 cuts. Okay. Now this simple note right here can save a lot of frustration and time, and you can see in just a few mouse clicks how fast it was for me to put in those edits. So the only thing that you need to understand is that everything that you put in here is saved to the job of NC Simul, and then you'll have it every single time afterwards as well. And as we continue through, we can see that for each, if I go to the following, you can do this for every single tool. And after you're done with your document, all you need to do is simply say create the PDF, and NC Simul generates a PDF document automatically. Now that the PDF is being generated, we can then send that in an email, put that on our network, and we can see that I'm just going to zoom out just a little bit. That's my cover page, all my tooling operations and what the tools machined. And then finally, the individual tool setup sheets for each tool. And this was very quick. This was automatic. NC Simul ran, it took a picture of the tool and what it machined, and it grabbed all the information that came right from your CAM system and filled in all this information. And this is customizable, so you can ask us if you want to change the template around your logo, your company logo as well, and we can definitely do that. Next on the list of things to show you is the NC Simul feature for doing tool length optimization and verification. Now, the tool length optimization allows you to run a simulation, and it optimizes the length of the tool that is sticking out. And allow me to explain. When you run a project, you have the tool sticking out just so far on the project because you don't know if one operation that's using that tool is going to have enough tool length, but you know for a fact that on another operation it has more than enough. Well, instead of guessing what the minimum stick out length needs to be, the software will allow you automatically to, it gives you the exact value of the minimum stick out. So inside of this project, what I'm going to do is go inside of my options for simulation. We'll go to simulation. And if we go into collisions, alarms, we have material removal with holders and the length optimization under head. This also gives us a clearance value of an extra 200,000. So it's going to tell me the minimum stick out plus 200,000, or a buffer zone, if you will. So now I'm just going to run a regular simulation, and you'll notice that, again, NC Simul, it's very clean, it's very fast. I'm just going to tell it to get to the end result because I just want it to get there as fast as possible. And once it's done, it's going to give me a list of the defined length that came from my tool definition and the minimum length required to have more rigid tools. Now, rigidity is the name of the game when it comes to finishing, high-speed mills. Every quarter inch, half an inch it makes a huge difference when doing this type of machining operation. Now that the simulation is coming to an end, it's going to give me the detailed report in my information tab at the bottom of the screen. So here it's almost complete. Now that the simulation is complete, I'm just going to open up my information tab. We'll put this at the bottom here. In the info tab at the very bottom, it gives me the defined length and the minimum length required. So tool number 4, if I click on tool number 4, it automatically brings me up to that point in my program so I can see exactly where it detected the minimum stick out length. So here, if I clicked on tool 4, it says, okay, you defined a length of 2 inch 625. However, you only need to stick out 2 inches 60 thousandths to not have a collision of the holder, of the clamp, the holder, and the stock, or the holder and the part. Again, for tool number 1, I just clicked on it and it said the minimum stick out length is 1 inch 300 thousandths. And I can just go right down the list and it shows me the defined length and the minimum length required. Now all I need to do is simply go inside of my tool library, take the defined length, and just subtract or just put in the minimum length requirement that NC Signal gave me, and then generate my shop floor documentation from that, and then the operator knows the minimum length that each tool needs to be. The length verification and the length optimization work hand in hand. The length verification, how that works is if you're having a lot of collisions with tools that are too short, the software will do the opposite. It'll actually extend the tool out to the minimum length and tell you, okay, this is what you defined. However, you're having many collisions with it. You need to have the tool sticking out this far. And then it does the opposite. So that's what NC Signal is doing in the background when it's running the simulation, is it's constantly checking for the minimum stick out or how much you need to draw the tool back in. Next, what I'm going to be going over with you is understanding how NC Signal can save time for doing probing optimization. Probing is a very difficult area for a lot of people, especially when you have very complex macros. So if you're using such as Renishaw Plus, Renishaw Inspection Plus software, you know that a lot of people don't utilize all of its functionality. It's able to do measurements of parts. It's basically a CMM on a CNC machine. Well, a lot of people don't understand it because it's very difficult to set up and do sometimes. So with NC Signal Machine, you're able to see exactly what is being probed, what is being calculated for the probing trajectory, and also doing the shifts for the work coordinate systems. And I'll explain first right here. For this first ingot right here that I have, my work coordinate system, or my G54 on the real machine, is in the ballpark but not truly in the center. If we look from the top view, we can see that my X and my Y and my Z, it's not perfectly centered to my stock model. That's because the probe needs to come in and measure from 3 points to calculate the center point. Here, as we click through the probing operation, it does the calibration of the probe, and then after it's done doing the probing routine, you'll see that NC Signal recalculates the center point to the actual center of our stock. Now, if I was to shift the stock model off-center even more and rerun the probing routine, it will update that for the G54 location. You'll also notice that in the Z-axis, it's not perfectly set to the top of the stock. That's because, again, the probe needs to come down, touch the top of the stock, set the G54, and then do a 3-point check around the stock model. Here, if we run the simulation, the first thing that the probe is going to do, it's going to calibrate on the ring. Then it's going to come and probe the piece. Z, our first point, second, and then third. And now it does the recalculation of the G54 after the M00 is executed. So now we can see that NC Simul knows where that true center point is. If I was to change one of these values in my G-code program, it will recalculate and retriangulate. This is a 9823 Renishaw cycle that if I change the A, the B, or the C, it's going to move this around just basically like clockwise or counterclockwise depending on the angle that you put in. So if I change this to A 90, B 100, and C 170, from any 3 points, you're able to calculate a center point. So now if I stop the decoding and I say I want to reload the probing, you're going to notice that those 3 points are going to be changed. That's because NC Simul calculates it exactly the same way that your machine tool does. How this saves a lot of time is because you're able to do the troubleshooting from the computer while the machine is in production on another project. You don't want to get to the machine and say, oh, well, I got to go back and forth and have to play around with the probing operation because I have an oblong part. No, you want to do that right from your simulator, which will allow you to check for it right away, and it gives you that instant feedback right from the software. So here you can see that NC Simul is reloading with the probing. So the blue means that NC Simul is decoding the regular ISO code, and the red means it's doing the probing operation in the background. Now that it is done, we can see that if I move this to my top view, you can see that those points have been changed dramatically. However, it still was able to calculate the center point to the center of the ingot right here. Now, the last thing of probing that I want to show you is that NC Simul will also probe machine features. Now, this is a very key aspect because if you're trying to do a measurement or a test, if you will, of a stock size or a machine feature size before going on to the next operation, such as a tool break check, pocket check, the software will allow you to move forward from that if you have any issues. So I'm going to make one of the tools cut undersize. Here I have a probing operation that's going to come in and probe a 4-inch diameter pocket in the center of this first ingot. So I describe tool number 2 as 0.75. However, hypothetically, and I'm over-exaggerating here, if this tool is cutting undersize, such as 50 thousandths, which in the grand scheme of things is not realistic, but I'm just showing you this for demonstration. If I click Save and click OK, and if I rerun the probing, the software will know exactly what size that tool cut that pocket out, and it will give me an error message if the probe is exceeded or is outside of tolerance of that 4 inches. So right now it's doing the reloading of the probing, and we're going to see exactly what it's going to tell me the issue is. It's going to give me all the variable calculations, and pound 138, which is my real number that the probe is trying to detect, will give me the value that it probed to. So here we can see that just by changing one of my tools definition, the probe came in and said it is out of tolerance. So the probe cycle had to go back in and remachine it with another tool, and then it reprobed it again to check for size. So here, if we go down, I'm going to turn off the toolpath preview, and let's press play. So now, once I start beginning the simulation, it's going to come in, probe the top of the stock. It does the engraving operation, and now it's going to machine the pocket. After it's done machining the pocket, the probe comes back in and it needs to check for the size of this pocket. So this is where the pocket failed, and we need to go inside and grab another tool to machine this pocket out. And that's how the software is able to detect and move forward with all the different types of probing. Now, if I back up and I go to the probe operation where it's checking here, I'm going to turn on the toolpath preview up to this point. If I go to my variables tab, we can actually look at pound 138 and see exactly what the probe equated to. So here we can see that after it was done machining the pocket again, it passed. So if we go back to the very first time that it checked the hole, you can see that it measured 3.950, a deviation of 50 thousandths, which is in violation of my probing routine. Therefore, it gave me my out of tolerance error. The last thing that I'm going to show you inside of NC Simula Machine is optimization, and how doing optimization will greatly reduce air cuts and also keep a constant chip load on your machining parts. In optimization, what we do is we take your current G-code program and make it better by removing air cuts and also keeping a constant chip load on the part. Here we have just a basic optimized project that was done for a customer, and the time savings was quite dramatic. So here, what I'm going to do is I'm just going to organize these windows a little bit easier for everybody. Here we can see a few different colors represented here. Right now, if I double-click on one of these pieces of wireframe, you can see that the feed rate is at 14.6. If I double-click on the blue over here, it's at F45. Double-click on the red, it's at F max. These are the three basic colors right now that I have designated for feed rates and rapids for the tools in this project. The optimization works by taking this project and going into, if I go to the optimization, I can say I want to run an optimization by taking all of my tools, clicking OK, and doing the cutting calculation. What NC Simula does during this process is it's running a simulation and it's detecting when the tool is outside of material, when it's inside of material, and every other time that the tool is engaged into the material, or if it's rapiding across the top of the stock, or if it's cutting past center line. Now with optimization, you're now able to rewrite the G-code program and put it back into the simulator to check for additional issues. While this is running through, I just want to kind of maybe ask if there's anybody, I don't know if there's a specific question or concern regarding the optimization or any of the features that I've shown, but if there's anything that you'd like to follow up on afterwards, please feel free to send any questions and I'll be sure to answer them promptly.
So if anybody has any questions, you guys can feel free to type those in the dashboard at this time. Is that the end of your presentation, John?
I have just one more thing to show, and then I'll be all set. It's the results of the optimization that's being ran right now. Right now, it's
calculating
the actual. It's doing the calculation right now, and I just want to show people that this is not a very small project. I want to show that it doesn't matter the size. It is very quick, and the time savings that you're going to have is very dramatic, and it's almost done right now.
It's not like a cooking show where they turn around and pull the finished bake.
No.
Out of the
no. So the other thing too is with the optimization, you can customize the tools. You can put in the tool parameters that you want from the tool manufacturer for the cutting feed rates and so on. So you can apply those to the optimization as well. So now that the optimization is completely ran through, now we can take and look at the project for removing air cuts and increasing the chip load. So just right now, the calculated time, and I'm just going to show you guys really quick just how much time it's going to be saved just by removing only the air cuts. We're not even going to get into constant shutdown. If I just remove air cuts from this project, you're going to see how dramatic the time savings are. The other thing too is we also have a module inside of NC Simul which allows you to do the pre-processing of projects as well for one machine to another, which is NC Simul CAM, which we can get into later on if anybody has any questions on that as well. So now for the optimization, I want to do a air cut optimization of all the tools. My security and my engaging. When I'm outside material, I want to have a cutting value of 300 inches a minute. When I'm tangent, I'll do a cutting value of 200 inches a minute. And when I'm tangent and retract, I'll just rapid. And once I click OK, this is how fast it's able to do the calculation. Once it's done, it's going to give me the optimized value, and you're going to see that the tool paths on the screen are going to change color because it's showing you the different feed rates that it's spliced in. We never change your trajectory. We only put in a G0 or a G1 depending on the preference that you've had. So now, once the optimization is complete, we can see the optimization at the optimization status tab down at the bottom. In the info tab, we can see exactly the time savings that we have. So for this project right here, it saved them 25 minutes alone just on removing air cuts. Now for them, that 25 minutes on a part that ran every single day that was already optimized from their CAM system, mind you, just that 25 minutes allowed them to buy another machine by the end of the fiscal year. That 25 minutes can be the difference of many other factors. And I really wanted to emphasize on this because the seconds count inside of manufacturing, especially on projects that are ran constantly. So this is the end of my presentation. The only other thing that I want to show is NC Simul CAM, but that can be shown at a different time. If anybody has any questions on this, please feel free to ask, and I'll be more than willing to go over anything that was shown today.
Well, one question that came in, and it was during the time when you were running the optimization, it said, can this be used with a Mastercam router?
Like just a router machine? Yes. So if you're using optimization, yes, it can. So we can take the G code from the routing machine and optimize it, yes.
All right, good deal. So John, I'm going to take control back for a moment. Actually, I need to. All right, so if there's any other questions, feel free to plug them in at this time and we'll answer them. But I want to thank everybody for attending our webinar today. If you have any questions or want any further information, you can either respond or reply to the email that you received confirming the webinar today through GoToMeeting. That will come to us. Or you can email us at info@3hti.com. Hopefully that's real easy to remember. Or you could give us a call at 866-624-3HTI, or you can contact me directly and I will get you the appropriate information or connect you with the appropriate individual that can help you and answer your questions. So John, thanks a lot for being with us today and for helping me host this webinar. We hope that you, everyone who attended, got a lot out of this. So once again, thank you for attending. Have an awesome day and let us know if we can help you out with anything else. Take care. That's going to conclude our webinar. Thanks.